Assalamu alaikum wa rahmatullahi wa barakatuh. How's it going, guys? Uh, this is the last video for this year 10, final term revision. First of all, we're going to start with the rules of indices. We got a couple of questions that we need to make sure that you understand these. 7 to the power of minus 1. It's the same as 1 over 7 to the power of 1, because once we showcase the reciprocal of the number, we're going to change the index to the different sign or the opposite sign. If it was negative, it becomes positive, and if it was positive, it becomes negative. And anything powered to 0 equals 1. And that's it. Another thing to bear in mind, for example, when we have x to power of 3 times the width, x power 4. In this case, we're going to write x, but we're going to add the powers. In multiplication, we add the powers. So 3 plus 4, x equals 7, power 7. Okay? And in division, it's quite opposite. Here in this case, we're going to subtract the powers. So 4 minus 2, x will be powered to 2 then. And when we have x power 3 powered by another power, here we're going to multiply the powers. So x power 3 times 2, which is x going to be x power 6. Okay? And the square root of x is the same as x power half. You should know that by now. Alright? And you should know that the top and the bottom, the top is power and the bottom is root. You should know that. So if we have x power 2 over 3, the top is power, meaning all of it is going to be powered by 2, which is the top is power. But the square root here, the root here will be cubic because we have power 3. So here you go. Angles and parallel lines. We have 4 types of angles and parallel lines. The first one, or the first letter, let's say, it is the Z letter. We are having 2 angles here, alternating. This one, if this one is 60, the other one is going to be 60 as well. So we call these alternate angles. And we know for a fact that alternate angles are actually equal. Bear that in mind. Showing the letter Z. Also, if it was like this, here would be the same thing as this one here. Alternate angles. The second one is corresponding angles. Corresponding angles is showing as, or we use letter F to help us to find out the corresponding angles. So this letter F here. As I mentioned, these angles are in parallel lines, like this. So if this angle equal this angle, then we apply the rule of alternate angles. These are alternate. And the same thing, if this is equal to this, then they are corresponding because they're showing the letter F. And then corresponding angles, again, the angles are equal here. Okay, so if this was, let's say, 120, this will be also 120, showing the letter F. The third one is vertically opposite angles. Vertically opposite angles, they are equal. So vertically opposite angles, they are equal angles. Let me show you what I'm saying. If this is, let's say, 90, or let's say 90, or let's say 85, this will be also 85 because they are opposite to each other and they are equal. Number 4, in the last angle, the co-interior angle. Actually, in this case, I made it the last one because it's not like the others. Here, the angles are adding up to 180. Let me show you what I'm saying. These are 2 parallel lines, okay? If I have this angle, which is 150, I will know for a fact that this angle is 30 because these 2 are co-interior. So if I know 150, all I'm gonna do is I'm gonna take away 150 from 180. giving the value of 30, which is for the other co-interior angle. So then let's have an example here. We need to find the value of x. What can you see here? Obviously, letter F. Here you go. So x is going to be, without any doubt, 37. Okay? If I needed to find this value, which is, let's say, y. Here, it differs. What can you notice here? That these are vertically opposite angles. So this is actually 37. And you will know for a fact that if this is 37 and they are alternate, this is also 37. You will know that. But now we are searching for the value of y. You know for a fact that when you have co-interior angles, all you gotta do is you take away from 180. And that's the case. So you take away 37 from 180, which is gonna be 143. Okay? Histograms. So let's see what is all about histograms. Histograms are basically bar charts where the bars may have unequal widths. The vertical axis is always labeled frequency. You know that for a fact that the vertical axis is always, this one here, is always labeled as the frequency density. And there are no gaps between the bars. The frequency density, which is the most important thing here, because we're gonna dedicate a vertical axis for it, it is going to be frequency over the class width. If you're asking about the frequency, it will be given for you. As for the class width, is also will be given to you, but not directly. You're gonna have to figure out yourself, which I'm gonna show you now. So we have this example, but before we go through the example, let's say the last point here, rearranging the formula for the frequency density gives the frequency equals frequency density times class width, which we already know it's easy. Just remember that the frequency density is going to be equal to frequency over the class width. So the frequency equals frequency density times class width. That's another formula to show. Let's look at this example. The table below gives information about the distance in miles traveled by 240 people. To get to a concert, draw a histogram to show this information. So the question only gave you this. The question only gave you the distance and the frequency. Don't look at this now. Okay. So the distance in miles, we have from 0 to 10, which the distance is lying between two bounds here, more than 0 and less than or equal to 10. And the frequency, or the number of people who were running or ran this distance, there are 66. And for this one here, 78 people. And for this one is 72. And lastly, for that last one is 24 people. How to know the class width? Because as you know, the frequency density is going to equal the frequency over the class width. But we need to find not just the frequency density, we need to find the class width before finding the frequency density. So all you gotta do is just take the second pound and subtract it from the first pound. So 10 minus 0 is going to be 10. 25 minus 10 is going to be 15. 45 minus 25 is going to be 20. 60 minus 45 is going to be 15. Now you're gonna draw a third column and you're gonna put these results like shown here. Then you find the frequency density. I have my distance. My frequency. I have my class width. Now I can find my frequency density, which is going to be frequency divided by the class width. Here you go. Here are the results, as shown. Now all you gotta do is to draw. Remember the fact that you need to dedicate the frequency density in the vertical axis, not the horizontal. Meaning that the distance will be shown on the horizontal axis, as shown here. Then you're gonna match, okay, from 0 to 10, which is this one here. From 0 to 10, you're gonna draw like this, all right, and you put a point above 0. You start from above 10. Sorry, you start from 0. You go to 10. You put the point above the 0, above the 10, and then you go up until you reach 6.6 because the frequency density is 6.6, and somewhere here between 6 and 7. So 6.6 is going to be here above the mid by 1 square. And then you connect, here you go, that's a bar chart, okay? Collection bar chart is basically a histogram. And that's it. So from 0 to 25, this one here, you go up until where? 3.6. 5.2. Here you go. This one. And so on. And that's for the histograms. Fractions are very important, guys. Fractions, we have three types of fractions. We have the proper fractions. We have the improper fractions, guys. And we have the mixed fractions or mixed numbers. And we're going to apply calculations on these. We're going to add, we're going to subtract, we're going to multiply, we're going to divide. The proper fractions are basically having a fraction with the numerator less than the denominator. Let's see the timer here. All right, very good. Or this one. So that's proper because the numerator is smaller than the denominator. Okay. As for the improper, actually the quite opposite is 3 over 2, for example. The numerator is bigger than the denominator, which is really important to understand. A mixed number will be shown like this, for example. That's a mixed number. Now, let's add. Let's see, we have this, for example. Let's multiply. 3 over 4 times it with 2 over 7. In multiplication, it's really easy. All you gotta do is just multiply the numerator by the numerator and the denominator by the denominator. 3 times 2 is 6. And 7 times 4 is 28. And simplify if possible. That's an even number, so it's simplifiable to by dividing by 2. So if you divide by 2 here, divide by 2 here, this is going to be 3 over 14. Because 2 times 14 is 28. So 3 over 14 is my final answer, and which is a proper fraction. Okay, if we have a mixed number, and I'm asked to add here with another mixed number. Change the mixed numbers into improper fractions, then add. 7 times 1 plus 1. 7 times 1 is what? Is 7. Plus 1 is 8. 8 over 7. Plus. 4 times 2 is 8. 8 plus 3 is 11. 11 over what? Over 4. Now I cannot add because I have different denominators. I've changed my mixed numbers into fractions, but I cannot add the fractions because in adding or subtracting, I'm going to have to find the same, or let's say the same denominator. So I'm going to multiply both sides to get to the same factor or common factor, which is going to be 28 in this case. 4 times 7 here and 7 times 4 there. And whatever you do down, you do up. Similarly. This will be given 32 up, 28 down, plus 77 over 28. Now having the same denominator, I can add. (109 over 28). Expanding here, it's really important when you expand the expressions. All you gotta do is put in the 5 inside. 5 times 2x is going to be 10x, and 5 times minus 5 is going to be minus 25. Simple as that. We need to find the perimeter here, guys. The perimeter is given to you in this question, but you need to find the value of x to find the values of each side of this triangle. Perimeter, you know, basically we're gonna add all the sides together. So it's basically 4x plus x plus 2 plus 3x equals 45 because it's given to us in the question. By collecting like terms and rearranging, we can know the value of x. So this term here doesn't go with the letters, so I'm going to put it there. So it becomes 4x plus x plus 3x equals 45 minus 2, which is going to be shown as 43. Now we're going to add the like term with our letters. 4 plus 1 is 5, 5 plus 3 is 8x. And you divide both sides by 8, so the answer would be improper fraction was 43 over 8. That's the value of x. Here we have to find this value of an angle. This is a right angle triangle, okay? And in right angle triangle, we perform very amazing ratios, given the mnemonic صح كح توا, or in English سكتوا, okay? But I prefer the Arabic one, صح كح توا. So صح is for the sine ratio, sine theta, which is in this case x, which we need to find, equals the opposite. I'm going to tell you what does it mean, the opposite here, over the hypotenuse. The next one is kah. So cosine, obviously. Cosine theta, the same thing is going here, guys. The adjacent over what? Over h, which is hypotenuse. And the last one, tawwa, which is going to be tangent theta equals the opposite over the adjacent. In this case, we need to find the value of theta, but we have two sides. We have this and that. So what do you call this and what do you call that? It's pretty easy. The side that opposing the right angle, we call it hypotenuse. Any side opposing the right angle, which is hypotenuse, which is in this case, it's a slope. And the side opposing the theta, we call it the opposite. Simple as that. Leaving the side which is stick to the theta, which we call adjacent, and that's why we call it adjacent. It's beside theta, that's why we call it adjacent. Now, what we have in the question, we have adjacent and we have the opposite. So we're going to be dealing with these two. So we're going to search for a rule or ratio that has these both in it. So we have adjacent and we have opposite. So we're going to use the tangent here. Tangent x, because we don't know, we need to find it, this one, equals the opposite, which is going to be 5.7 over what? Over 3.7, which is the adjacent. To find the value of x, you're going to plot this in the calculator. You're going to do shift 10 to the power minus 1, and you're going to put this value on your calculator. Let's do this together. Let me open my calculator. Let's change the mode to the normal mode. I've been dealing with graphs earlier. So, like I said, shift, then you're going to press tan, and you're going to put the value as a fraction, obviously here, 5.7 as it is. Go down, 3.7, which is going to be 57.011. Round to two decimal places. It is going to be 57.01 degrees. That's the value of x. The question is done. Here we need to factorize. We need to find the highest common factor between the two terms, this and that. It's going to be 12 and x. And you take this as a divisor and divide. When you divide 12x by 12x, it's going to be just y. So when you divide 12xy by 12x, is going to be just y. And when you divide 12x by when you divide 25 minus 25x by 12x, it is going to be just 2. So here you go. With this triangle, we need to find the area. The area of a triangle. It's really, really important, guys. To find the area of a non-right angle triangle, usually when we find the area of a right angle triangle, we just multiply the half by the base by the height. And that's it. But here we have non-right angle triangle, so we're going to follow this rule, which is half times A times B times sine C. Okay? This angle is C, so this side is going to be A, and this side is going to be B. Half times with 5 times with 6 times with sine 60. Let's do it. Okay, so 1 over 2, which is the half here, times it with 5, times it with 6, times it with sine 60. Let's see the result. It is going to be 12.990. Obviously, it's an area, so centimeter squared. If you want to round to the nearest whole number, it's going to be 13 centimeters squared. This is how you find the area. If they asked you to find the length of AB, okay, so this one, all right, that will be a different case. But we got the area only. Now, we have the probability of the biased dice will land on 5 is 0.4. So the probability is given to you. Nasr is going to roll the dice 300 times. So work out the estimate, an estimate for the number of times that the dice will land on 5. Just very simple, guys. Just take 0.4 times with 300. As simple as that. 0.4 times with 300. It's going to be 120. Take care of yourself. 120 times. We need to show this part of a fraction as a percentage. Show this as a fraction, 50 over 80, and multiply by 100. 0 goes off with 0. Five over 8 times with 100. It's going to be 62.5%. That was it. Thank you for listening. I hope you the best of luck. Assalamu alaikum.